This is section 3.6 of Honors Algebra 2, problem solving with systems of equations. So we get to do word problems. I want to review with you the four-step problem solving process that we used in the first unit, and we're going to use it again here. The first step is to define your variables. And notice that's plural here because now we're going to have two variables and we're going to end up with two equations, a system of equations, and we're going to solve for both variables. So define your variables. Organize the information, ultimately leading to two separate equations of the same two variables. Then solve the equations, plural again, and check your solution and answer the question. So I'm just going to do two examples with you here in this video, and then set you on your way. Example number 1. To rent their printing press, a newspaper charges $30 per hour during the day and $10.50 per hour at night. If a company paid $411 for 28 hours of use, how many hours were they charged at the daytime rate, and how many hours at the nighttime rate? So often, on these problems, you'll be asked to find two things, and those two things indicate what your two variables should be. So our first step is to define our variables. If we want to know the daytime rate and the nighttime rate, or how many hours they were charged at the daytime rate, how many hours they were charged at the nighttime rate, maybe we'll call them D and N. So let's say that D equal the number of hours at the daytime rate and let N be the number of hours at the nighttime rate. Okay, now what do we know about D and N? Well, we know that the daytime rate is $30 per hour. So if they were charged $30 per hour for D hours, then the total they were charged during the daytime was 30 times D. Now the nighttime rate is $10.50 per hour, and we're saying that they used N hours at night. So the total they were charged for night was $10.50 times N. So let's note what we know about the total amount that they were charged. Total amount that they were charged is the daytime amount, which is 30D, plus the nighttime amount, which is 10.5 or 1050N. And we know what that number is. We know that that is $411. That is the amount that they paid total. So that's one equation. Now we need another equation. We know that total, they've used 28 hours of use. So what can we say about the total number of hours? Total number of hours would be the amount that they used during the day plus the amount that they used at night, D plus N. And that is 28. So we ended up with two equations. Part 3, we solved those two equations as a system. So, looks like we could pretty easily use substitution here because we can take the second equation, D plus N equals 28, and we could solve it for D or for N. Let's say we solve that for D. So D would be 28 minus N. We can substitute that into the first equation for D. So we would have 30 times 28 minus N plus 10.5N equals 411. 30 times 28 is 840. Then minus 30N plus 10.5N equals 411. So then we've got 840 minus 19.5N equals 411. If we subtract 840 to the other side, then negative 19.5N equals negative 429. And dividing both sides by negative 19.5 tells us that N is exactly 22. Okay, we're not done solving the system yet. We still need to find d. So we go back. We know that d was 28 minus n, so we do 28 minus 22. So d must be 6. And then we could check our answer. 22 plus 6 makes 28, so that's good. And we could check that 22 times 30 plus 10.5 times 6 is indeed at 411. Now we need to answer the question. So the question was, how many hours were they charged at the daytime rate and how many hours at the nighttime rate? They were charged 6 hours at the daytime rate and 22 hours at the nighttime rate. It would charge 6 hours at the daytime rate and 22 hours at the nighttime rate. Example number 2. Somewhat of a different kind of problem. To measure the speed of the jet stream, a weather service plane flew east 1,800 kilometers with the jet stream as a tailwind, and then back west with the jet stream now as a headwind. The eastbound flight took 2 hours, and the westbound flight took 3 hours and 20 minutes. Find the speed of the jet stream and the airstream of the plane, the airspeed of the plane. We want to find both the speed of the jet stream, the wind, how fast the wind is going, and how fast the plane is going within that wind, so without regard to the wind. We want to be able to piece those two things together. Tailwind means that it's flowing with the plane. The plane is flowing in the same direction, so it's helping it. A headwind means it's flowing against the plane, and it's hurting the plane. It's decreasing the overall velocity of the plane. So, step number 1. Let's define our variables. Again, two things we want to know: the speed of the jet stream and the speed of the plane. So, let's call those. Let's say let J equal the speed of the jet stream, which is the wind, and that will be in kilometers per hour. And let P be the speed of the plane in still air. So if there was no wind, how fast would the plane be going? And again, that would be in kilometers per hour. Okay, now step 2. Let's organize our information. I'm going to do that in the form of this table here. We know eastbound, which was the first leg of the trip, they had a tailwind, so the wind was helping them. So this is with the wind. If they're going with the wind, then the velocity or the speed of the wind is helping the speed of the plane. So we're going to add them together. We're going to take J plus P. And this is called the ground speed. It's the speed they're going relative to the ground. So that means the wind and the plane together. With the wind is helping it, we're going to add it. Going westbound, though, they were going against the wind, and so it was hurting the plane. So we need to take the speed of the plane minus the speed of the wind. And maybe we should rewrite with the wind as being P plus J rather than J plus P, though it's the same thing. But it would help to be consistent. Okay. So P plus J with the wind, P minus J against the wind. Now, how much time are they taking? Well, eastbound it took 2 hours. Westbound it took 3 hours and 20 minutes. Well, we need everything in hours. So we're going to say 3 1/3 hours. 20 minutes is 1/3 of an hour. The distance that they're traveling, well, remember that distance equals the rate times the time. So I just need to multiply the speed by the time and I'll get the distance. So that's 2 times P plus J on the eastbound trip, and 3 1/3, which is 10/3, times P minus J on the westbound trip. Now, where it is taking off and landing isn't moving, right? So the distance it's traveling going east is the same as the distance it's traveling going west. That means that this box needs to be equal to this box. That means that these two boxes are really the same value. We could write them as one equation, but that one equation would have two variables, and that's not going to help us. But instead, we actually know what that distance is. We were told it's 1,800 kilometers. So we can set the eastbound box equal to 1,800, and we can set the westbound box equal to 1,800. That will give us two separate equations, both involving the same variables, and we'll be able to solve it. So let's write our equations. We've got 2 times P plus J equals 1,800, and 10/3 times P minus J equals 1,800. Now, those look like complicated equations, but they're really not, because we could take the first one, we could divide both sides by 2, and just get P plus J equals 900. And we can take the second one and multiply both sides by 3/10 and get P minus J equals 540. Or multiplying by the reciprocal of 10/3, multiplying by 3/10. That gives us two very nice equations that are easily solved by linear combination, because if we just add them together the way that they are, J's cancel, we get 2P equals 900 plus 540, so 1440, which means that P is 720. And then we could plug that in to either one of our original equations, and 720 plus J equals 900, so J, the speed of the jet stream, is 180. And then let's answer the question. The speed of the plane is 720 kilometers per hour, and the speed of the jet stream is 180 kilometers per hour. And now your immediate practice problem, which is very similar to example number 1. Complete the problem-solving process, all 4 steps on this problem. Jerry asked the bank teller to cash a $390 check using $20 bills and $50 bills. If the teller gave him a total of 15 bills, how many of each type of bill did he receive? How many $20 bills? How many $50 bills? Again, it's very similar to example number 1. And that is the end of section 3.6.